My name is Muhamad Asyraf bin Abdul Fazila, matrix number A158409. I will present about the general introduction of polymer processing. Okay, basically, polymer is a compound consisting of a long chain molecule, each molecule made out of repeating units connected together. There are three types of polymer. First, thermoplastic polymer, which can be melt or dissolved in solvent to form solutions. Second, thermosetting polymer. It has molecular chains that are chemically bonded together to form three-dimensional network. And lastly, elastomer. Elastomer are rubber or rubber-like material. And polymer processing. Polymer processing is defined as an engineering activity concerned with operation carried out on polymeric material or system to increase their utility.
The objective of this project are to analyzing the difference between injection molding and compression molding, and to analyzing the result of tensile strength and Young modulus for different type of polymer.
In some fundamental respects, the mechanical properties of polymer vary from those of metals and ceramics, and the design methods used for them vary academically. The special properties also require special manufacturing methods. The real breakthrough came when chemists worked out to process to make the big molecules with the smallest units thereof. Out of the about 10 normal ones, the engineer was immediately faced with polymers and modifications of them with hundreds of new materials of notable and varied properties. The number continues to rise. It is well known some of the manufacturing steps within the two techniques of compression molding and injection molding will sever the polymer, thereby greatly reducing the length of the polymer. The so-called self-reinforced polymer, also known as single polymer composites, control the micromorphology and structure of polymer materials through physical methods such as altering and processing rate. Okay. Next, polymer system and process conditions aiming at the weak links in the traditional polymer molding process in order to achieve the internal reinforcing effect of polymer materials. Okay.
Polypropylene. Based on previous study, polypropylene can be processed through many converting methods such as injection molding and extrusion. Polypropylene suitable for items such as tray, pails and bottle. Next, PVC, polyvinyl chloride. Polyvinyl chloride can be processed through extrusion, injection molding and blow molding. PVC usually used to produce pipe and coating for electrical cable. Next, ABS. Based on previous study, ABS can be processed using compression and injection molding, extrusion, calendering, and blow molding. Example of ABS product is electronic housing, auto part, pipe fitting, and Lego toys. Last one, polyethylene. Based on previous study, polyethylene can be processed using many techniques such as extrusion, injection molding, and compression molding. There are many types of polyethylene. The first one is high density polyethylene, low density polyethylene, and last one, ultra high molecular weight polyethylene. Example of ultra high molecular weight polyethylene are medical device and bulletproof vest.
I will talk about the methodology. First, injection molding. Injection molding is the most commonly used manufacturing process for the production of plastic parts. Injection molding is capable of processing a wide variety of products, which vary greatly in their size, complexity, and application. An injection molding machine, raw materials, and a mold are required in the injection molding process. Both thermoplastic and thermoset polymer can be processed through the injection molding. For processing thermoplastic, the plastic is melt in the injection molding machine and then forced into the mold, where it's cooled and solidifies into the final part and can be ejected. Next, for compression molding. Compression molding is the most developed molding technology for fiber reinforced composite. Preheated plastic material is placed in an open, heated mold cavity. The mold is then closed and the material inside is forced to contact all internal mold areas. Heat and pressure are maintained until the molding material has cured. And lastly, for tensile test. Tensile sample, due to the restriction of aerial mode, the specimen produced using injection molding were different in dimension from the ones produced using compression molding. In our analysis, the geometry of tensile specimens and standard values is depend on the researcher. Surely it will follow standard test method for tensile properties of polymer.
Size of the product. Usually, compression molding is used in produce the big size of the product, while the injection molding usually in the small size of the product. Then, in terms of production time, usually compression molding took significantly longer than the injection molding in producing the product. Then, in terms of quantity, usually the injection molding will use in order to produce the large quantity of a product, while the compression molding will use in the medium and low quantity of the product. Then in terms of shape of the final product, compression molding usually used in order to produce the simple design, while the injection molding is used for the complex design. So for second part is to study about the mechanical properties of the recycled polymer. The mechanical properties that we choose is the tensile strength and Young modulus. So for the first recycled polymer is PP. So there is a research where the process in making a PP is being altered, and by doing that there is some increment of the tensile strength and Young modulus. The increment is as much as 26% in increasing of tensile strength and 31% in increasement of Young modulus. So the parameter that had been altered in production it is cooling time, holding time, and also holding pressure. So by altering that, it can increase the Young modulus and also the tensile strength. So for the second recycled polymer is PVC. There is a research where the surface roughness is being measured on how it will affect the tensile strength, and the result for that research is it can be concluded that the lower the surface roughness, the higher the tensile strength. So for the third recycled polymer is about the ABS. There is also a research where the percentage of the recycled ABS material is measured then compared to their tensile strength, and it can be shown that when the percentage of recycled ABS in the polymer is higher, the ultimate tensile strength also will become lesser. So, and for the last part is which is for the PE, polyethylene. So about the PE, there also almost the same research as the PP, where some of the parameter is being altered in measuring the tensile strength and Young modulus of the altering process. Thank you.
Okay, as a conclusion for our project, in a nutshell, we can see that all the mechanical properties of tensile for each of the polymer has their own unique flaws. From these four polymers, it cannot be concluded which one that have the highest tensile strength compared to other, because there are too many parameters that need to keep constant. The comparison between injection molding and compression molding can be seen that both of the process has their own advantage and disadvantages. Actually, the process must be depends on the polymer that will be used to see if it is suitable or not for the process, injection molding or compression molding. Thank you very much.